Louk is now going to address some of the expert issues, in particular his perception of why contract projects fail. Louk, please lead us off. Thank you very much.
Thank you. Good morning. Yes, I would start by saying that in order to avoid delays, first you need to identify them and measure them. Therefore, I will be speaking about the importance of the baseline program and the program updates in general. First off, okay, here we are. First off, why projects fail? I think that first and foremost, we should discuss openly that projects fail because contractors trying to get as many contracts as possible in an economic environment that is difficult. They are being really aggressive when they are bidding for projects. Therefore, they're underpricing their jobs, and also they are imposing themselves onto impossible time schedules. So the projects, even from day one, they're set to fail, because I understand that an owner might like to have a new bridge in 3 months or a new airport in 4 months. However, this is not possible, even if the contract says so. Then we have poor contract drafting and contract management. As Simon also explained, you might have a contract that is maybe too rigid, so people are trying to find ways to work around that, or maybe too loose, where people are actually spending lots and lots of time arguing whether they should follow one paragraph or the other. And then we have seen cases where the contractors do not actually use a contract manager. Therefore, practically no one is really following the contract to the letter. Then we have unforeseen events and changes. We now live in the COVID-19 era, where this needs to be addressed both in contracts and in the real life of the construction project. And also we have changes of scope, changes of design that actually create friction between the parties, and in most cases, delays as well. We have the visibility and monitoring of the design. The design is always a moot point because different parties have different understandings on whether the design is finalized or not and scrutinized or not. Therefore, the visibility everyone has on the design itself and the monitoring of the progress of the design is also a really key factor that actually causes projects to fail. Last but not least, we have the poor monitoring and the poor record keeping that actually lead to the poor reporting and the poorly defined critical path. Being an engineer myself, I understand that in the construction site, it might be actually too boring to be keeping notes about everything, to keep records about all the small jobs and tasks and sub-projects that you have running in parallel. However, if you just don't keep proper records and these records find their way into a poor report, and then you define your critical path poorly, you are setting your project to fail, because practically no one knows whether the project is in delay or not, and no one knows whether the project is actually progressing as it should have or not. Now I will be talking about the importance of the baseline that is often neglected. The baseline is the first program of the project, is also the first contractual requirement. The wrong definition of the scope within the baseline can lead to delays. The wrong logic can also lead to the wrong definition of the critical path and wrong focus of works. If we are missing any contractual milestones, this also may lead to critical delays and delayed damages. And also, you should not forget, especially in cases where we have dispute resolution, that the baseline is measured to measure delays against. And now I will walk you through an example of a correct baseline against the wrong baseline. Let's take a simple construction project. We need to build a building with 3 floors, and the total construction time is 15 months. Also, we need to deliver the second floor after 9 months. So a correct and really high level baseline would look like this. We would have the foundation works, then the first floor, then the second floor, followed by the delivery of the second floor, then the third floor, test and commissioning, and taking over date. However, I also acknowledge that during the first stages of a project, the parties are really rushing into building the project. And since they want to draft and commonly accept the baseline, they might accept a baseline that might be wrong. This simple example comes from a real case where we had a baseline where the foundation works would be followed by the second floor, then it would be followed by the first floor, and then we would have the third floor. You don't have to be a top engineer to understand that you're not supposed to be building the second floor before the first floor. And also we have the testing commissioning not properly linked with the overall program, and there was no taking over date. And that program was accepted. So let's now look at what happens if you have a wrong baseline accepted and you're trying to measure delays against the set program. Let's move forward on 1st of May 2021, where the first floor was completed. I have two questions for you. One, was the project in delay at that point? And if so, by how much? Normally, we measure delays against the baseline, and we are using what we call as-built dates of real events, practically. So if you compare the finish date of the first floor against the planned date of the first floor, you will see that there is 1 month of difference. So someone would argue that, okay, the project is in 1 month of delay. However, if you also measure the delivery of the second floor in the wrong baseline against the same activity in the program update, you will see that there are 7 months of delay. So someone else would argue in a claim that there are 7 months of delay in this job. But then we also have another layer of complexity where if you measure the taking over date in the wrong baseline that has not actually been put in against the forecast taking over date of the job at that point, you might measure 5 months of delay. So here's the question. Is the project in 1 month of delay, 5 months, or 7 months? Actually, the correct answer is none of the above, because if the planner, the contractor, had properly drafted their baseline, we would see that the first floor was planned to be actually built within October and December 2020. And if we measure against that date, the actual as-built date that we have, the correct number is 4 months of delay. Therefore, the project on that stage was in 4 months of delay, but the wrong baseline did not really help the parties to understand the position. This is why the baseline is so important. Also, not only the baseline is important, but also the program updates are important. Why so? Because they establish and identify the actual critical path. You should note that the actual critical path takes 80% of our day job. We're trying to identify the actual critical path because contemporaneously this was not defined properly. Therefore, is a major point of dispute between the parties. Then the program updates establish a good control and monitoring of the project itself. Being a construction engineer myself in the past, I know how important it is to know whether your project is on time or in delay, and by how much, as discussed. It instills trust between the stakeholders. So when you are, if you're the contractor and you're putting in a claim, it's easier to get your claim across if the owner trusts that you're telling the truth and not the other way around. It identifies problems early and can allow quick resolution. So the parties would have a different approach to the job if they would think that they were in 1 month of delay, as explained in the previous example, and a different approach if they thought that they were in 7 months of delay. And program updates also set the standards for proper record keeping. This means that if you have a really good program and you are updating this correctly and in a timely manner, it actually kind of forces your team to behave accordingly. If you have a program of 5,000 activities, your planner will be asking for input from all stakeholders within the actual project, just to be sure that the program updates are correct. And last but not least, the program updates, along with the baseline, can be used for EOT requests, early warnings, and notifications. In order to go back to the title of this presentation, how do we avoid delays? To be simply put, we avoid delays by telling the truth contemporaneously. I know this is not the case because we've seen so many projects get into delay, and we always know that there are difference of opinion between the different parties. However, if you follow these simple rules of program drafting and program updating, it will be easier for you to get consensus contemporaneously and actually get your EOTs, get your claims across, and resolve all delays contemporaneously. And that is the proper way to do this. And thank you. That would be all. And now Simon, we'll move to Ewen.
Luke, thank you very much. A very good summary of some of the key issues in my experience that caused significant delays in large construction projects. particularly the failure to deal with impact on the baseline. Ewen, from your perspective, can you give us some expert analysis on the different methodologies that you use to assess these issues?
Yes, thank you, Simon and Luke and Colin. And good morning, everybody. I'm going to talk a little bit about the importance of record keeping in delay disputes in arbitration, whilst also discussing the implications of COVID-19 in delay and disruption more generally. And I'm going to start by going through some of the characteristics of COVID-19 delays and how its effect might be analysed before setting out the methodologies and the records that are needed for such an analysis. But firstly, good record keeping can significantly assist in the success of a party's case in arbitration and can potentially even avoid disputes altogether. And without good records in an arbitration, even the best delay experts in the world can be neutralised, because a good delay expert report is not just founded on robust and detailed analysis, but also on the quality of records or evidence supporting that analysis. Now, COVID-19 has introduced new causes of loss of productivity that will not have been so prevalent in historic loss of productivity analyses. Indeed, the variable effects of the pandemic could result in some surprising rerouting of the critical path, which I will hopefully show in the next two slides. So, in this first slide, we can see a simple project commencing at the beginning of March with a critical path proceeding through the design and then construction before testing and commissioning leading to completion. In the second slide, I've updated the programme for progress at the beginning of April, and we can see that the design has been able to progress. That's illustrated by the blue bar, because designers have been able to work from home, whilst procurement has stalled with no progress. And this results in the critical path switching out of design and into procurement. So therefore, it's important to recognise that different disciplines of the project may be affected in different ways, and these differences will need to be accounted for in any loss of productivity analysis in order to assess the impact of COVID-19. And COVID-19 is also likely to have affected construction projects in different ways at different times. And I've shown this on my next slide. Which shows effectively that productivity achieved on site may have dropped even prior to any lockdown measures being imposed by national governments, as there may have been shortages of labour through absenteeism from sickness or self-isolation or travel restrictions. Indeed, on international contracts, the influence of COVID-19 may have been even greater, as different countries are in different phases of the pandemic. Then there's a second phase, which is as lockdown measures are imposed by national governments, and this is likely to have had an even greater adverse effect on productivity, as contractors are forced to work under more restricted site operating procedures. For example, these may sort of include the minimizing the number of workers involved with a particular task, or using one-way systems to move around the site. And then thirdly, even as lockdown measures are relaxed, productivity may not return to pre-lockdown or undisrupted levels, as there may still be, for example, phased or staggered returns to working, or still some site operating procedures causing restrictions. So COVID-19 is very likely to have caused delay to construction projects, and parties will be keen to adopt strategies that will be able to recover lost time, such as working longer hours. However, as we'll just have a look at this, my next slide. It should be recognised that working longer hours can, in itself, lead to a loss of productivity. Don't think by doubling the number of hours people work to carry out the same task will equate to that task being carried out at half the time. Because we can see in this slide here, which is based on some empirical studies of productivities achieved on site under particular conditions, then increasing the hours from 40 hours on the horizontal axis to 60 hours, if you follow the red line up, the average loss of productivity that was found was a 20% drop. And of course, if you think about it, working longer hours on site, people are going to get fatigued, and there is very likely to be a drop in productivity. So how can we expect such losses of productivity to be evidenced in arbitration? Well, there are actually many methods, and they broadly fall into two categories. Firstly, productivity-based methods, and secondly, cost-based methods. And these are shown here on this slide, which is actually based upon the UK's Society Construction Laws Delay and Disruption Protocol. The most commonly accepted method is the measured mile approach, which compares the level of productivity achieved during a period of disruption with that that was achieved during a period when the works were not disrupted. And reasons why this method of assessment is often preferred include assessing productivity that is specific to a particular site, and because it compares the actual productivity that could be achieved with the productivity that could still be achieved but for the disruption. And because of that, it doesn't rely on tender allowances, which might be unrealistic, or data from other sites or studies that are less relevant to the particular project in question. In addition, such analyses are also more likely to be supported by site diaries and from personnel on site, which may be helpful if these witnesses are providing factual witness statements in arbitration. Now, in my next slide, I'm going to walk you through an example before then coming to the records that are needed. And we can see on this slide, I've got here the performance of a tunnel boring machine planning to carry out a 400-metre long drive between the 2nd of March and the 4th of April. And we can see that the planned productivity, which is illustrated by the green line, was 11.8 metres a day. However, the actual productivity achieved during a period of undisrupted progress is illustrated by the blue line in window 2, which is the second block along on the chart, where after a learning curve where the parties, where the gangs were getting to know the work, there was an undisrupted period of progress of 11.1 metres a day. And that is important because that is the benchmark by which any loss of productivity should be measured, as it demonstrates the project productivity that can actually be achieved without disruption and doesn't rely on the possibly unrealistic tender allowances. Then if we follow the blue line along, we follow it into window 3, which is a pre-lockdown phase, and we can see that the productivity drops to 5.4 metres per day, perhaps due to crew members self-isolating. And then we follow the actual productivity to window 4, and we can see that during lockdown itself, the productivity dropped to just 2 metres a day because of probably all sorts of issues with supply chain issues, instructions, changing access points, etc. And then finally, in the last window, the productivity picks up as lockdown measures are relaxed. Whilst additional hours were worked, the contractor would still have to comply with site operating procedures. So whereas the productivity increased in the period, it does not increase commensurate with the number of increased hours worked on site, as this in itself, as I was talking earlier, introduced less productive working. The loss of productivity can then be assessed each day or for each period and valued by assessing the cost for the additional people, equipment and materials. So in this example, in the period of lockdown, the actual productivity was 2 meters a day in window 4, which can be compared with the undisrupted productivity of 11.1 meters per day. So the loss of productivity is 11.1 minus 2, or 9.1 meters a day. And this can be used to explain any extended duration in carrying out these works and valued by costing the resources used. Cost-based methods, if you ever come across those in arbitration, by themselves analyse differences between planned and actual expenditure without having first analysed any loss of productivity in terms of resources. Accordingly, they're generally a less robust approach than project-specific studies, but can still be a useful cross-check. So it's evident that you're going to need sufficiently detailed records, which are key to a good analysis of loss of productivity leading to delay. So what are the records that need to be kept? And hopefully my final slide will appear here. I've put up a selection of records here, but firstly, records relevant to progress and analysing loss of productivity should be generated contemporaneously or at the time. And these will include, as we see here, programs, progress records, resource records, and cost records. Programs should record the actual progress of all activities within the scope of works at regular intervals, and potentially not just at the sort of regular monthly intervals that are common reporting intervals in construction contracts, but also at particular events when you go into lockdown or any special measures are made. You should be trying to capture the status of the works at that particular point. And all outstanding works in the program should be realistic and capable of achievement when you update your program. Ideally, programs should be resourced. Often at BlackRock, we see programs that aren't resourced, and that's why perhaps the project is in dispute. And it should identify principal equipment and other resources. Progress records. Progress records should be kept daily. There might be arguments to be arguments made to that they should be even more regular than that on particular specific activities, but they should also address at what times and where people and equipment was being utilised. Typical records might include various reports recording manpower, deliveries, site conditions, working hours, major plant and equipment used, and these reports, or perhaps daily site diaries, should also include specific details of issues that might be the cause of a loss of productivity, such as a specific site operating procedure that has been imposed. But some of the most persuasive records I've found in my experience are webcam footage and progress photographs, which should be clearly annotated, as these represent the true status of the progress firsthand. And this is opposed to, say, a program that has had a planner interpret the data to insert the progress data into the program. And sometimes at BlackRock, we find that that's not always been done accurately. So primary records that are unequivocal, showing the status of the progress, are particularly valuable. You may find these records in detailed weekly, monthly progress reports for identifying causes of delay, but you're probably going to need some further detailed analysis to establish the effects of any loss of productivity, because we can see from the example I gave, it's very data hungry. You're going to need metrics. You're going to have to record all causes of delay. Design is often very important as well. As we've seen on this in my presentation, the design can continue to proceed with people working from home, whereas procurement might stall, the supply chains dry up. But if you're still trying to track the design, you're going to need details of all the drawings, not just the most current drawing, but all the drawing revisions, so you can tell the full story. So I think my time is up. So resource records and cost records detail the similar information that is recorded on this slide. And I do have details of these slides if you wanted any further information. But I'd also just point you finally to the detailed list of typical records contained in Appendix B of the UK's SCL delay and disruption protocol, because that actually sets out all these programs, progress records, and further records, including correspondent, and it is a very useful aid memoir or list that parties could use. So that concludes my piece, Simon.
Thank you very much, Ewan. That was very informative.